This is lesson 5.3, task 2. All right, so we're going to compare linear functions still. So we want to look at different types of representations. So we're going to compare linear functions. 4 linear functions are shown, represented in different ways. Identify the function that has the greatest value when x is 15. All right, so the first one gives us an equation. They give us an equation. All we have to do is substitute the 15 in for x. 2 times 15 is 30, plus 4 is 34. So this one's very easy to find, very straightforward. All right, they give us a verbal description. As x increases by 1, h of x increases by 2. When x is 4, h of x equals 5. All right, so this looks a little bit odd, but this is -5, and over here you see it's -4, so this is actually increased by 1. If you look on a number line, -4 is 1 unit to the right of -5. So when it says x increases by 1, that's what that means. All right, and then it says h of x increases by 2. That's why it's been multiplied by 2 here. All right, so h of x equals 2x minus 3. If you simplify all of this together, you get h of x equals 2x minus 3, and then we just plug in the 15 here. Again, 2 times 15 is 30, minus 3 is 27. All right, so let's see if I can write these down. So f of 15 is 34. H of 15 is 27. All right, it says, how is the verbal description used to write a rule for h of x? Well, you just have to take the words, the verbal description, and put it into the equation. Okay? All right, g of x, this is g. You can see g here on the graph. G of x is given to you as a graph. So you have a y-intercept. You can find that by looking at the graph. And you can do rise over run. So you can do 1, 2, 3, 4, 5 over 1 to get the slope. Or you can use 2 points like they've used the formula. Difference of y's over difference of x's to get the slope. Once you have a y-intercept and a slope, you write the equation. Y equals mx plus b, so 5x minus 1 is your equation. Plug in 15. So for this one, g of 15 equals 74. All right, I think we have one more. Well, let's see what the question says. How is the graph used to write a rule for g of x? Select all that apply. All right, so when you look at the graph, we found the y-intercept. Points on the graph are used to find the slope. That's true, because they did use the points right here to find the slope. Points are used to find the domain and range. That's not important right now. The graph is used to locate the y-intercept. Yes, we did locate the y-intercept by finding where it crossed the y on the line, so that would apply. All right, now we're given j of x. Okay, so we're given points. They're going to use 2 points. So they're using the first 2 points, 7 minus 4 and 1 minus 0 here for your difference of y's over difference of x's. So they plugged in 0 to get the y-intercept. That's given right here. So your y-intercept is 4. Your slope is 3. So again, we can plug it into y equals mx plus b. So y equals 3x plus 4 is our equation. We want to know what happens when it is 15. All right, so I think this is a typo. This is saying f of x, but this should be our function j of x because they've got 3x plus 4 here. So this is going to be our j of x. That's just a typo. So j of 15 equals 49. All right, so how is the table of values used to write a rule for j of x? Select all that apply. Coordinate pairs in the table are used to find the domain and range. Again, we don't need the domain and range right now. Coordinate pairs are read to find the slope, yes. And coordinate pairs are used to find the y-intercept, yes. This time they use the ordered pair, 0, 4, to identify the y-intercept. All right, so the function g has the greatest value when x is 15. Okay, how did they determine that? Well, they looked at the 4 functions, and g of 15 is 74, and that is the greatest out of the 4 outputs here. So that's how they determined that g has the greatest output. All right, then it says identify the function that has the least x-intercept. All right, so when you're looking for the x-intercept, okay, that means you're going to have x and 0. Okay, your x-intercept is always going to be on the x-axis, so your y has to be 0 for that to happen. All right, so to find the least x-intercept, we're going to plug 0 in for f of x. Remember, f of x is your y value. So if I'm looking for my x-intercept, plug 0 in for y, and then solve for x. So here I'm going to subtract 4 and divide by 2. So that would be -2. Okay? I don't know what this is. All right. Plug in 0. You're going to add 1 and then divide by 5. So x equals 1/5. 1/5 can be written as 0.2. Right here, if we substitute 0 for y, then we add 3 and divide by 2. So x equals 3/2. 3/2 can be written as 1.5. And then 0 equals, that's where this is. This is in the, this has been spaced over and went down a line. So that actually, this line right here should be over here. So 0 equals 4x plus 4. So I'm going to subtract 4 and divide by 4 and get -1. And I think that x should be right here as well. So for f of x, our x-intercept is -2. For g of x, our x-intercept is 0.2. H of x, the x-intercept is 1.5. And j of x is -1. So if you want to find the least, that means the smallest. So the smallest would be -2. Okay? And it says, why are the function values set equal to 0? Well, that's just definition of what an x-intercept is. X-intercept, if you think about it on a graph, you know, an x-intercept is going to be somewhere on the x-axis. Every point on the x-axis has a y of 0, because this is 1, this is -1. So everything on this axis has a y of 0. All right. Let's see if that's it. That is all for task 2. All right, 5.3, task 3. This is our final task. So we're going to compare linear functions. And this is to analyze models involving linear functions. All right, 2-cylinder candles have different heights and different burn rates. They are lit at the same time and allowed to burn out. Use the graph for candle 1 and table for candle 2 to answer the following. So here's the graph for table or candle 1. It says this is height in inches and this is time in hours. So it looks like before it began to burn, it was 8 inches tall. And it looks like it got to 0 inches after 10 hours. All right, candle 2, this is our table of values. At time 0, it was 6 inches tall. So this one was not as tall as the other one. But it looks like it's burning a ½ inch per hour. This one was burning a little faster than that. So at 1 inch, it had dropped to 7. This was burning for 1 inch an hour. And in the table, this is burning a ½ inch an hour. So we'll see how that compares. Okay? All right, it says determine which candle burns out first. All right, so the candle burns out when its height is 0 inches, which means that the graph has reached, it's the x-axis, but on here they're using T. So we have to put T. And so candle 1 burns out in 10 hours. All right, explain how to obtain candle 2's rate of change from the table. All right, the rate of change is the change in height divided by the change in time from the first 2 rows in the table. The change in height is 5.5 minus 6, which is -0.5, and the change in time is 1 minus 0, which is 1. So your rate of change is difference of y's over difference of x's, or negative 0.5 inches per hour. And I kind of looked at that. When I looked at the table, I can see that it's going down a half an inch every hour. Okay, so you can see that rate of change using the table. All right. It says the function that gives the candle's height h in inches at time t in hours is h of t equals negative 0.5 t plus 6. The candle burns out when h of t equals 0. So again, we're going to plug 0 in for h of t, and then we're going to subtract 6 and divide by negative 0.5. So negative 6 divided by 1/2, or negative 0.5, equals 12. So candle 2 burns out in 12 hours, where candle 1 burned out in 10 hours. All right, so it says describe another way to find the time it takes candle 2 to burn out. Select all that apply. Graph the function and find the t-intercept. So you could do that using the 6 as your y-intercept and your slope as your rate of change, and you could keep going down until you got to the t-intercept. We don't need the h-intercept. Use the table to find the value of h when t is 0, so we could do that. Use the table when the value, oh wait a minute, this is the one we need. Use the table to find the value of t. T is what we need, not h. All right, which candle burns out first? Candle 1 was 10 hours, candle 2 was 12 hours, so candle 1 burns out first. And then it says determine which of the two candles has the same height. Determine when the two candles have the same height. The candles have the same height when their height functions have the same value. So you can see right here when they cross, this is candle 2, this is candle 1, and they cross at 6.667 and 2.667. Okay, so that's using the graphing calculator to graph those two functions. All right, so using a graphing calculator shows that the graphs of the height functions intersect. So 6 2/3 hours after they are lit, both candles have a height of 2 2/3 inches. The following spreadsheets give approximations of when the candles have the same height. Spreadsheet 1, candles have about the same height at t equals 7. So if you see t equals 7, 2.4 and 2.5. All right, candles have about the same height at 6.7. So you can see here it went from 0 to 10 hours. Here they've broke it down into smaller increments. So here it goes from 6 hours to 7 hours, and they've broken it down to where you get even closer, and you can see around 6.7 how much closer they are. So it says which spreadsheet gives a better approximation. That would be spreadsheet 2, because the increments are smaller. That's a better approximation. And if you continue in the pattern from the previous two spreadsheets, explain how to get an even more precise approximation when the candles have the same height. So build a spreadsheet showing t values from I would say 6.6 to 6.7 using an increment of 0.05. I meant to put 0.01, so let's see, 6.6, 6.7, increments of 0.01. I don't know why I put 0.05. I said 0.05. But you see how these went by increments of 1. So if you break it down to 6.6 to 6.7 and go by increments of 0.1 again, or 0.01 moves it one more decimal place, that breaks it down and gets even more precise or even closer approximation. All right, that's all for task 3. If you have any questions, please let me know.